Okay, so let's take a look at how we're going to do this synthesis problem set. So we're going to just do a few of these today. Problem one is just to synthesize this compound. It's an arrow ring attached to a cyclohexane ring with some functional groups also attached to the arrow ring. How are we going to make this? These are our carbon sources. So let's think about how we're going to make this. Let's first do a retrosynthetic analysis of the compound that we want to make. So I see right away I need to make a cyclohexane ring somehow. I'm going to construct it. At this point, I'm thinking Diels-Alder, and if we could make this compound, and we were given the butadiene, that we can just do a Diels-Alder reaction to go ahead and do this cyclization. So then we have to make this compound, and the first thing I notice is that I'm going to have to create a carbon-carbon bond because I had to start from benzene. So if we can make this, I can turn this into the Grignard reagent and make a carbon-carbon bond. This is going to be just a sequence of electrophilic aromatic substitution reactions in the right order to get the right regiochemistry. So let's go ahead. So the first thing, these were our carbon sources, but we realized that we can do functional group transformations and we can hydrolyze this ester and we get a 2-carbon unit and a 1-carbon unit, so we can make anything we need from those. We also have acetone, so from acetone we can make any 3-carbon chain with functional groups on it. We can make the alcohol, and we can make this alcohol. We could make the alkene with a carbon-carbon bond here, so we could then get the oxygen over here to make that alcohol. So we can make whatever we need using chemistry from Organic 1. So with that realization, let's go ahead and do our synthesis. So the first thing I'm going to think about is we have to do a bunch of electrophilic addition reactions to benzene. We've gone and made all of the reagents we need. So the first step is we made acetyl chloride. We made that by hydrolyzing that ester and then converting the carboxylic acid to acetyl chloride. We do this in the presence of a Lewis acid catalyst, just a simple electrophilic aromatic substitution. We can put in the next group. We can put on either the bromine or the nitro group. I'm going to put the nitro group on first because we have a meta director. Nitro is a very good electrophile, so this reaction will go in high yield and it'll go to the meta position. Now these are both meta directors. This is a very deactivated ring, but bromination reactions will go because the bromonium ion is also a very good electrophile. So we can go ahead and do our bromination with Br2 and a Lewis acid catalyst and get to this position. So the next thing we have to do is go about making this carbon-carbon bond. So how are we going to make that carbon-carbon bond? We have this. We're just going to turn this into a Grignard, but in order to do that, we have to protect this carbonyl group. So we'll just use ethylene glycol and install the acetal. Then we'll go ahead and add the magnesium. This is protected, quite stable under basic conditions, so we can make this magnesium bromide, and we're going to add to that magnesium bromide some acetaldehyde, and we'll form a carbon-carbon bond between this carbon and this carbon, and we'll end up getting the alcohol, the secondary alcohol, and we can just do a simple elimination reaction from that. We need some kind of strong base. I've used tert-butyl butoxide, strong enough base to pull off this proton and also kick off the hydroxide and get us our styrene compound, our substituted styrene compound. So the next thing we have to do is just simply go ahead and do this Diels-Alder reaction. When we do that Diels-Alder reaction, we get this thing as the alkene. We have to reduce this alkene. We also have to reduce, we forgot about it, but we have to reduce this nitro group to the amino group, the aniline. We could do this. Now, we actually can do it under mild enough conditions that we should be able to selectively reduce the nitro group and the carbon-carbon double bond, probably without touching the ketone. But if we did, that's not a problem because we can just use a mild oxidizing agent like PCC, and that's going to oxidize the secondary alcohol back to the ketone, and we have our final product. It was that simple.